welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics, that is of class 11 part 1. This is your class 10th class which we had done 9th class in the last sessions, and where we had completed your unit 1 here, which is your about physical worlds. Now talking about unit 2, which is your units and measurement, that what we have to discuss here, and of course that is being important one. So let's go further, but before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel so that many and maximum people can get their information at once, and even though you can also enjoy the video as well. Talking about last, we had done about the ranges and the order of weights here. Now today we will discuss about the another one, which is about measurement of the masses and range and order of masses here. So first we'll discuss that, but before starting with this, first we'll discuss the measurement of time, and then after that we'll continue with the same. Measurement of time. Before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and maximum people can get the information at once, and even you can also enjoy the video as well. In terms of measurement of time, that to measure any time interval we need a clock. We know use an atomic standard of time, which is based on the periodic vibrations produced that is produced in a cesium atom, and this is basics of the cesium clock as well, sometimes called atomic clock, that is used in the national standard. Such standards are available in many laboratories. In a cesium atomic clock, the second is taken as the time atomic that needed for here, that has been 91926317770 vibrations of radiation, that is corresponding to the transitions between the two hyperfine levels of the ground state of the cesium-133 atom. The vibrations of the cesium atom regulate the rate of this cesium atom that clock, just as a vibration of a balanced wheel that regulate an ordinary wrist watch, or the vibrations of the small quartz crystal regulate a quartz wrist watch as well. In the same way, the cesium atom clocks that very accurate in principle. They provide the portable portable standards and the national standard of time interval, which is second, as well as the frequency is maintained through 4 cesium atom clocks, and a cesium atom clocks is used at National Physical Laboratory, which is NPL, New Delhi, to maintain the Indian standard of time. In our country, the NPL has been the responsibility to maintenance and improvement of physical standards, including that of time, frequency, etc. Note that the Indian Standard Time is linked into the set of atomic clocks, that the efficient cesium atom clock that are so accurate, and they are in part of uncertainty in their realization, as that is being 1 into 10 to the power minus 13, which we can say that is one part in 10 to the power 13. This implies that the uncertainty gained over time by such a device is less than 1 part of 10 to the power 13. They lose or gain no more than 3, that is in 1 year. In a view of the tremendous accuracy, the time measured in the SI unit of the length that has been expressed in the terms of the path length, and that light travels in a certain interval of time, which is 1 upon 1 by 299,792,458 of a second, and that is we had done discussed here. And the time interval of the event that can be considered across the universe, that is very over very wide range, and that is being range of the orders, sometimes typical time intervals as well. In the same way, you may notice that there is an intersecting coincidence between the numbers of appearing, and that has longest and the shortest length of the object in the universe, that is of 10 to the power 41 intermediately, and we'll discuss this as well. This is the number 10 to the power 41 comes up again. The another we'll discuss about the range of the order of the masses as well. which is the largest and the smallest masses of the object of the universe in 10 to the power 41 twice, is the same or coincidence between these large numbers purely accidental. Let's go for the range here. Range and order of masses. So for the same, we have your objects, then we have your mass, which is kg in kg. Okay, so that we discussed here. And so further, before going to in the detail about it, we will discuss about some of the objects. That is your, we have your electron. So first we'll discuss about the electron, which we have a mass in kg, that is of 10 to the power minus 30. We have proton, 10 to the power minus 27. Uranium atom, which is 10 to the power minus 25. Red blood cell, 10 to the power minus 13. Dust particles, 10 to the power minus 9. Raindrop, 10 to the power minus 6. Mosquito, 10 to the power minus 5. Grape, 10 to the power minus 3. Human, 10 to the power minus 10 to the power 2. Automobile, 10 to the power 3. Then we have your, after automobile, we have your Boeing 747 aircraft, 10 to the power 8. Moon, 10 to the power 23. Earth, 10 to the power 25. Sun, 10 to the power 30. Then Milky Way galaxy, that is 10 to the power 41. And observable universe, 10 to the power 55. Okay, that we have here. So this was the range and order of masses, and I will discuss about the accuracy, precisions, and instrument and electron measurement that we discussed here. So we go for the same. Accuracy, precision of instrument and error in measurement. So here measurement is the foundation of the experimental science and technology, where the result experiment that of every measurement instrument that contains some uncertainty. The uncertainty is called an error. Every calculated quantity which is based on the measured and as also as an error, we shall distinguish between the two terms accuracy and precision. Accuracy of the measurement is measured of close to the measured value in the true value of the quantity, and precision tells us about what resolvent. I will just write it down for you because this has been asked many times, and where many of the people are confused between this accuracy. Accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. This is called accuracy. Okay, now we talk about the precision. What is precision? Precision tells us about what resolution or limit the quantity is measured. Okay, that is about the precision. We will talk about it. Now further we go here, and that will discuss that the accuracy is measured may depend upon the several factors, including the limit of the resolutions of the measuring instrument. For example, suppose the true value of a certain length is there about 3.678 centimeter. In one experiment using the measurement of the instrument of the resolution 0.1 centimeter, it is measured 3.5. So while the another experimented that device is the resolution 0.01 and that is 0.38. So of course the measurement of the accuracy that closer to the true value but less precision, that its resolution is only 0.1 centimeter, while the second measurement is less accurate but more precise, that the every measurement is the approximate due to the error in the measurement, and in general the error is measurement that can be broadly classified as symmetric errors and the random errors. So we discuss about the symmetric and the random errors as well, and so we go for the same. In symmetric errors, this has been divided. The random errors has also been the part of here. So we'll discuss one by one this. So I'm talking about the symmetric errors, systematic errors. In this, the systematic errors are those errors which tend in the one direction, either positive or negative. Some of the sources of the systematic errors we have. The first we have is your instrumental errors. In terms of instrumental errors here, that arises from the errors due to the imperfect design or calibrations of the measuring instrument, zero errors in the instrument, etc. Like for example, that the temperature of the graduation of the thermometer that may be inadequate, calibrating it may be read 104 degree at the boiling point of water in STP. So whereas it should be read 100 degrees Celsius in a Werner caliper, that the zero mark of the Werner scale that may not coincide with the zero mark or the main scale, or simply the ordinary meter scale that may be worn off to the one end. Second is imperfection in experimental technique or procedure. Imperfection in experimental technique or procedure. In this, talking about that to determine the temperature of a human body, a thermometer placed under the armpit will always give a temperature lower than an actual value of the body temperature. Other external conditions such as changes in the temperature, humidity, wind velocity, etc. during the experiment of the systematic affect that the measurement as well. Third is your personal error. In talking about personal error that arises due to an individual bias, lack of proper setting, that apart apertures and the individual's carelessness in taking observation without observing the proper precautions, etc. For example, if you by habit always hold your head to a bit too far to the right while reading the positions of the needle here, and that on the scale that you will introduce an error by a parallax as well. So systematic errors that can be minimized by the improving the experimental technique, selecting better instrument and removing the personal bias as far as possible for a given setup. These errors may be eliminated to a certain extent, and the necessary corrections that may be applied to the readings as well. We'll talk about the random errors here, and of course that is after the random errors, we'll talk about more in the detail here. Random errors, then we have your least count errors as well. So yes, we'll go further. In terms of random errors here, that in random errors that are those errors which occurs irregularly and hence that are random with respect to the sign and size, and these can arise due to the random and unpredictable fluctuations in the experimental condition. Examples: unpredictable fluctuations in temperature, voltage, supply, mechanical vibrations of experimental setups, etc. Personal unbiased errors by the observer taking reading, etc. For example, when the same persons repeat the same observation, it will very likely that he may get a different reading every time. The next we have is your least count error. In least count error here, that is the smallest value that can be measured by the measuring instrument is called the least count here. And for that the least count error is an error that is associated with the resolution of the instrument. For example, a Werner caliper and that have a least count of as 0.1 centimeter, and as a spherometer that have a least count of 0.001 centimeter. Least count errors belongs to the category of the random errors, but within the limit of the size. It occurs with both systematic and the random errors. If we use a meter scale for a measurement of length, it may use graduation of 1 mm, division scale, spacing or interval, using instruments of the higher precision, improving the experimental technique, etc. We reduce the least count errors and repeating the observation several times and taking the arithmetic mean of the observation and the mean value that will be close to the true value and the measured quantity as well. So we go for the table next, and that will discuss about range and order of time interval. Let's go for the same. And of course that is being important, so you have to go ahead. Range and order of time interval. So here we have your event, and this is time interval. So let's go for the same. So we have your event. The first event we have lifespan of most unstable particle. which is 10 to the power minus 24. Time required for light to cross a nuclear distance. To cross a nuclear distance. That is 10 to the power minus 22. Another is period of X-ray. Which is your 10 to the power minus 19. Period of atomic vibration. Period of atomic vibrations, that is 10 to the power minus 15. Period of light wave. To the power minus 15. Next we have your wink of eye. Wink of period of radio wave, and then we have your period of light wave, period of X-ray, period of atomic vibrations, we have period of light wave, and then we have lifetime. Sorry, this is not okay. Wink of eye we go, that is 10 to the power minus 1. Then we have your lifetime. Of an excited state of an atom, which is 10 to the power minus 8. Period of radio wave. Which is your 10 to the power minus 6. Then we have another one, which is another next that we have to discuss here. Let's go for the same. So period of radio wave we had done. Now period of sound wave. Sound wave we have 10 to the power minus 3. Then we have time between successive human heartbeat. Successive human heartbeat, that is your 10 to the power 0. Then you have another one on travel time for light. Travel, that is travel time for light from moon to the earth, is 10 to the power 0. Then another we have travel time light from sun to earth, is 10 to the power 2. Then we have your rotation time period of a satellite. To the power 4. That we have rotation period of the earth. which is 10 to the power 5. And then we have your rotation and revolution of the period, that is 10 to the power 6. Revolution period of the earth, that is being 10 to the power 7. Travel time for the light from the nearest star is 10 to the power 8. Average human lifespan 10 to the power 9. Age of Egyptian pyramids 10 to the power 11. Time slice since dinosaurs became extinct 10 to the power 15. And age of a universe is 10 to the power 17. That is what we had discussed here. And now we continue with the next, and that will discuss about the absolute errors, relative errors, and percentile error. That is of course being the important one. You have to go through with this. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Please like, share, and subscribe to our channel so that many and maximum people can get the information at once in a video. You can also enjoy the video as well. In physics class 11 part 1, we had completed your unit 1, which is your physics and physical world. And then unit 2 we had dealing with units and measurement. Unit 3 is your motions in a straight line, motion on a plane, then laws of motion, work, inertia, and power, system and particles of the rotational inertia, and then gravitation. Then further we will continue with the part 2 as well. Stay tuned with us. Please go ahead with like, share, and subscribe. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion. So after that, rotation period of the earth we have, and then we have rotation and revolution period of the moon. And that is your 10 to the power 6. Revolution period of the earth, is 10 to the power 7. Then we have your travel time for light from nearest star is 10 to the power 8. Average human lifespan is 10 to the power 9. Age of Egyptian pyramids to the power 11. Then time since dinosaurs become extinct is 10 to the power 15. And age of the universe 10 to the power 17. So stay tuned with us, and please go ahead with like, share, and subscribe so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you. Keep supporting us. Your support is very important to us. Thank you.